So the question said that for a fixed positive integer n and each integer k between 0 and n, let a sub k denote the coefficient of x to the k in the expansion of 1 plus x to the nth power. And we want to compute the sum of all possible values of n for which there exists an index I, so a value for k, such that a sub I minus 1, 2 times a sub I, and 5 times a sub I plus 1 form a geometric series in that order. So the first thing we're going to notice is that the a sub I is exactly the binomial coefficient n choose I, since we are doing 1 plus x to the n. So that means that n choose I minus 1, 2 times n choose I, and 5 times n choose I plus 1 form a geometric series in that order. So that means that the middle term is going to be, the square of the middle term is equal to the product of the term before and after it. So we'll have 4 times n choose I squared is equal to 5 times the product of the other two. So from here, we can expand by the definition of binomial coefficients, and we'll get this pretty nasty equation, but most of it is in factorials. So one tip that we can keep in mind for factorials is that to lower the index of the factorial, we can remove the largest term. So for example, I factorial is going to be equal to I times I minus 1 factorial. And similarly, I plus 1 factorial is equal to I plus 1 times I factorial, n minus I factorial, and so on. And you'll notice that on the left-hand side, we have four terms that are factorials. And on the right-hand side, there's also 4 terms that are factorials. Since when we square it, we have 2 doubled into 4. And actually, each of the factorial terms on the left can pair with one of the factorial terms on the right to cancel out almost all of their terms with just one term remaining. Precisely, we'll get 4 times n minus I plus 1. So on the left-hand side, we have the second factorial term canceling out with an n minus I factorial on the right, leaving just n minus I plus 1 on the left. And similarly, I plus 1 factorial cancels out with one of the I factorials from the right, and that leaves an I plus 1 on the left. And on the right-hand side, we have 5 times I, which canceled out with I minus 1 factorial, times n minus I, which canceled out with n minus I minus 1. So from here, we can expand and move everything to one side. And now from here, we are going to isolate n. So we'll factor out n from the terms that have it, and then solve for n. So one thing that we'll keep in mind is that we can represent it as this form after dividing I minus 4 out. And this form is helpful because we'll notice that n is a positive integer. I is also a positive integer, so that means I minus 4 is greater than -3. I minus 4 is a factor of 20, and I plus 4 plus 20 over I minus 4, which is, that quantity is n, is also a positive integer. So from here, we'll use these 3 pieces of information to find all possible values of n. So from the first two, we'll notice that I minus 4 has to be one of these values since it's a factor of 20, and it's also at least -3. Oh, that should be greater than or equal to -3. And then we can organize our results in this table. So we have the values for I minus 4 and the corresponding values for I. And then we can work through them to get the corresponding values for n. And we know that n and I both have to be positive integers. So the only values for n are 17, 20, and 29, which have a sum of 66. So that is our final answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.